Hello, Namaste. Welcome back to the course on Geography Information System. As we were speaking in the module is on database and database management system, and when we were looking at what are different database. When we looked at a database management system, what is its architecture, how GIS can be integrated with the database management system. We looked at what do you mean by an entity. We looked at what do you mean by a relationship. Then what do you mean by ER relationship model. Then we looked at how and different types of relationships exist. For example, one is to one relationship, one is to many relationship, and is to many relationship. So now after we have understood that, we also understood how we represent an attribute. So now the next set here where we would in this particular class, probably we'll take it forward. We'll understand what are different keys that exist in a database, then how a database can be normalized. Normalization is also one of the very important techniques in order if you are trying to develop any databases. So how do you normalize a database, different forms of normalization of a database, that is what we would look at in this particular class. And as I said, we would look at database keys and normalization. So when we look at different types of keys, first of all, when I say keys, it is a key can be defined as a relation in any combination of columns whose values uniquely identify each tuple in a relation. When I say tuple, it is a row which has a data which has certain values. So that is nothing called as but a tuple. Now when you are looking at a key, it is a relation that is a combination of many columns. Okay, when I say columns, these are different values for each of these tuples. So when you look at each of these tuples are nothing but rows and columns have values. Rows are uniquely identified values. So when you look at it, for example, a student ID, a student name is a tuple, and or a student ID is a tuple. It can be name, etc. All of these are different values in different columns. Or his percentage of marks, his in 10th standard, 12th standard, all these are different columns. So that becomes a key. This key becomes a primary key if the attributes selected from a set of attributes are unique and it uniquely defined in terms of a tuple. So as I said, student ID is a unique number and it defines only a particular student, then it becomes a primary key. Okay, so let's say this primary key or a particular key is representing two different tables, connecting two different tables, and is actually acting as, maybe I can say it as a bridge between two different tables, and this particular key will be then called as a foreign key. Okay, so when I say a foreign key, it is a primary key of a table that becomes a foreign key in a final entity table, which means when you are building up the entire database, the primary key that you would have denoted maybe even connecting 2 or 3 or 4 more tables that are actually required for your entire database, then it becomes a foreign key for different tables that exist in that particular database. So key, it is a relationship or any combination of columns whose values are uniquely identified. These uniquely identified values are in a form of rows. Okay, in the form of rows are called tuples, and these tuples form a primary key. Okay, so when a primary key is defining a different number of different number of entities in different tables, and these are connecting different tables, then it becomes a foreign key for certain tables. So then it's called a foreign key. So this is different types of keys, and there are huge number of lists which we will also see in next slides. So when we go into the next, so if you have understood what is a primary key and a foreign key, well, that is what is extremely important for us. Okay, so the rest this is just for your understanding. So real GIS users should know most of these as a part of a database in order to understand how the database works. but if not, at least if you can understand the primary key and the foreign key, then the most of the operations is possible in terms of handling a database. And when you look at the technical key, these are the ones that are assigned by the system itself. Okay, if you have a database management system, it provides it assigns certain serial numbers which can be said as a technical key. Then you have a parent key. Parent key is the main key, or it can be even said this parent keys are nothing but primary keys. Okay, so when you look at this parent key, it forms a very main key, and if there is certain keys that follow this parent key, okay, then it is called as a child key. Okay, so it gets a child key can get as long as different levels of childs that you have. For example, in an entire model that you develop, the first, if you look at, is an institution. Then you have, let us say, a faculties. Then with the faculties, they will take 4 subjects. Let us say 4 subjects has so many students. Each student has its own ID. He or she has number of different subjects, all of these. So now you have a parent key, you have a child key. That child key has another child key, but for the second level of child key, this becomes a parent key. Okay, and similarly it goes on. So as the number of child key grows, your entire system grows as it goes. Okay, then you have a composite key, where when there are 2 keys for a particular table, 2 different keys for a particular table, then the 2 keys are called as composite keys. This can be a primary key also, or it can be any other alternate key. So it is not compulsory that both of these keys has to be a primary key. Okay, so this is called as a composite key. Fine. So we have looked at what is a primary key, what is a foreign key, what is a technical key. Technical key is from the system. We looked at what is parent key and child key. Parent key can be an your primary key itself having a lot number of child keys. So that is about. Then you have a composite key. Okay, so just to summarize all of these, we have keys. This is a minimum non-empty subset of an attributes. For example, let us say this is one of the database that we have developed. SS is nothing but the serial number, name is a name of that particular student, and you have an ID. Okay, so when we say key, SS can be your key. Okay, that's a serial number is uniquely defining. If it's uniquely defining, then it becomes a primary key. Okay, depending on its features, it has a different kind of a key. Then there is a concept called as super key. The superset of a key, one or more attributes that are actually taken collectively and can identify all other attributes, is nothing but a super key. Okay, for example, SS hash name. So if you have a serial number with the name, or your unique serial number with a name can actually define all other attributes in that particular table, then it's called as a super key if both of them are together. Then you have a candidate key. It can be more than one, or it can be many. So then ID can be one candidate key, SS your serial number can be one other candidate key. Then you have a primary key. Okay, any of those candidate keys which has a unique representation becomes a primary key. Okay, so then you have primary attributes. Attributes that make up a key is nothing but a primary key, primary attributes. Then you have degree. How many number of attributes do you have that is representing that entire database is nothing but a degree. Okay, so as I said, cardinality is nothing but you have number of rows representing different entities. Okay, so when you are looking at cardinality, you have how many number of tuples are there in that particular entire database becomes your cardinality of the database. So a data structure consisting of multiple parts or multiple rows is nothing but cardinality. If there are 100 rows, then it becomes its cardinality value is 100. Okay, now similarly, so I'm trying to give you the flavor of all understanding of what does what mean in a database. So this is very important in terms of in case someone is trying to look at the advanced database management systems. So these are some basics, very basic terminologies, but there is if you are looking at the advanced part of it, probably you will have to take up a database management course. So if you have learned the spatial analytics here and a database management course, probably you can become a super user in terms of looking at the spatial data in a GIS package. Okay, so as far as now we have learned what is a key, we have different types of key, that is primary key, we have looked at foreign key, we have looked at technical key, we have looked at even a composite key. Okay, we have looked at parent key and a child key, and once we have understood all of these, we looked at what do you mean by a cardinality and a degree. Degree is number of attributes that it has, and if there are many number of tuples, then it becomes a cardinality, or how many number of tuples are there in a particular system, then it becomes a cardinality of that particular system. Okay, and some more and whatever some of the terminologies that I defined before, let me define it in true sense in terms of what it means. Relationships, when I say relation, it is the files or attributes depicted as a table are known as relations. Okay, files or attributes, let us remove files, attributes that are depicted as a table is known as a relation. Now there is a student ID, student name, student age, class, then you have all the subjects that particular student has taken. So this all these attributes become a relations in that particular database. Okay, then tuple is a single row or a record in a database. Okay, or it is also called as tuple. So tuple or tuple, so it is nothing but a single row or a record in the entire database. Then you have fields. Be very careful when you have columns that is representing attribute values, each of these columns are called as fields. Okay, so different attributes, different fields, tuples, fields. Okay, so then domain, a physical or a logical distribution of an attribute. So this can be anywhere in the database. Okay, when you look at physical domain, identifies formats such as field type, for length of a column, normally 4 characters, etc. When you look at the logical domain, it identifies a valid pool of values, that is the range of values, it may be yes or no values, qualitative, quantitative values, whatever is there. So that becomes a logical domain, whereas physical domain gives you the field type, field length, etc. So this becomes a physical domain. Okay, so these are different terminologies that are used when you are looking at the database. Now when we are looking at data integrity, when you are looking at data usage, the very important part of why do you use a database is data integrity. So when you are looking at this, there are certain constraints in terms of maintaining the data integrity. So what are those constraints? Let us see in this particular lecture. It means to say that it provides a means of ensuring the changes made to the database does not result in the loss of data consistency. So whenever you are looking at the database, the very important point is why we call it as integrated part is that because it can maintain consistency of data. So whatever the changes you make, so your entire database has to be consistent, data consistent. That is what is called as a data integrity. So they normally guard against accidental damages to the database. Probably sometimes you delete certain things by mistake, or sometimes it is wiped out, all of this. So when they are actually guarding against any accidental damages that can happen. Okay, some without a knowledge, you type in something or you enter something into a database when you are using it as a super user. So all of these things has to be guarded in terms of, that's why it's called, it is all databases should have data integrity. That's exactly for the reason. So when we look at data integrity, there is something called as a referential integrity. When you are looking at referential integrity, it states that giving a non-null foreign key value. So foreign key is the one that may be a primary key in the database that has been inserted, but becomes a key that is connecting the other key, and for that particular data set this becomes a foreign key. So foreign key value must have a matching primary value somewhere in the reference table. Okay, if that is not there, then the referential identity or the referential integrity is missing in that particular data set. Then you have entity integrity. Entity integrity is no value in the primary key field can be null. Okay, please be careful. So when I give an assignment for certain set of students to define to develop an entire database with certain I mean probably using the names of students in the class, when they develop it, they give null values certain primary keys that they would have developed in different tables. So when the primary key cannot be null, if it is null, then it gives it is wrong entity integrity in terms of data integrity, and it cannot be null. So it has to have certain values that has to be maintained. Then you have domain integrity. This the value in the column, that is the field, okay, falls within the accepted range or not. For example, when you are actually measuring NDVI values are between -1 and +1. So if there is a value of +4, so that is a value that is out of range. So you have to maintain the integrity of that, saying that that is a wrong value. So it has to be maintained in a proper way. So that is what is called domain integrity, maintaining the domain knowledge in terms of what is the range of values that can be entered. Okay, it can be both qualitative or quantitative. I just gave an example of NDVI. So these are different data integrity constraints that are there. The next concept that the very important concept that we would understand in this today's class is normalization. When I say normalization, any data analysis method used during the design stage of a relational data. So relational data, so data that has relationship, entity that has relationships, and modeling, which allows to reduce storage space, data redundancy, inconsistent data, and ease the data maintenance. This is nothing but called as a normalization of a data. You are improving the way the data is through a data model, the way the data is stored, the data redundancy you are reducing, and inconsistent data is being removed. In terms, you are trying to improve the system of maintaining the data. That is nothing but a normalization. Okay, so it is a process of organizing the data for minimum data redundancy. When I say redundancy, let me see if I have an example here. For example, here this is an a table which is actually defining what is the name of an employee, how many hours that he has worked. Okay, maybe they have two cases. There is a case P1, there is a case P2. He has worked 24 hours in the case P1 and 6 hours in the case T2. For example, when we are actually defining here the entities, so when we define this particular entity, it is actually duplicated in two places just to mention how many hours he has worked in the case P2. But if in case this redundancy can be reduced, for example, M Smith unless the 34,000 is his salary, so P1 comma P2 unless say 24 comma 6 or in two different fields, so in the same row, so that would reduce the data redundancy. So when you are actually accessing the data in your entire database, when you give it as Smith, if you are searching Smith as a query, so it would give you two results, that is data redundancy. So in case if the same thing can give a single result giving the entire value, then it gives you then you are reducing the data redundancy in your entire database. That's a very good example. Even the Lee here is also having the same redundancy issues in terms of this database. Okay, so that is how you reduce your data redundancy. And normalization usually involves a database into two or more tables and defining a relationship between the tables. Okay, always when you are looking at normalization, you are speaking about relationships and the tables that are there. Entire database will be divided into tables, and each table is defining a relation. So that actually tells you what is a normalization. And the last thing is the process of creating an efficient, reliable, flexible, appropriate relational structure for storing information. So if someone says that you want to get, if there is a database which is actually defining the entire, probably let's say that there is a list of all students, what are the subjects they have taken, okay, what are the different degrees that they are, whether it is B Tech, BS, MS, MTech, okay, PhD, etc., and they have MPharm or any of those degrees, and then they have the marks scored, they have all those information that are stored. If by just, for example, a single primary key or single entity of information can give me the entire information of that particular student, okay, rather than looking at 2-3 places, then it becomes a very efficient way of storage, okay. And each of these may be stored in different tables and are related in terms of different relationships, then it becomes very efficient. That is what is done using a normalization, okay. So when we look at normalization, there are various reasons to normalize the database. The first reason is flexibility. Structure supports many ways to look at data. Okay, so because it has a certain structure, it can look at data in many ways. Then it has data integrity, that is data modification. For example, insert, update, delete, that happens in just one place. Okay, you don't need to search every table to modify that particular data. That's why the normalization is extremely important. If without normalization, you may have to look at different tables, different the same data would be redundant at every table and correct at every place. Then you have efficiency. One the very important part of normalization is efficiency, because it actually stores your space, also saves a time when you are actually looking at the entire database. For example, if someone is trying to access the very big database even through mobile phone, though mobile phones today are very efficient, but let us say in some places where the network is an issue and you have a mobile phone that's accessing the entire database with the network, it should be extremely efficient in terms of access of that particular database. So a very good example I had given it previously is your IRCTC website, the maybe a few years before and now. So when you looked at it in 2016-17 and now, you can see a stark change in terms of how the access is there, what is the speed, and how you can easily book your tickets. Okay, I'm not saying that you get a confirmed tickets, but you can look at what is availability, etc., in a much easier way, which never used to happen before. So that is a difference between efficient database that is normalized and a non-efficient database that is not normalized previously. Okay, so if someone asks me why do you need normalization, the first thing, as I previously said, your repetition anomaly can be easily removed in terms of the database. Update anomaly, where multiple tasks are involved, we can remove it. Then insertion anomaly, where you are looking at insertion of a data, that anomaly can also be removed in the database. So then this is because of the normalization. Then you have delete anomaly. When I say delete anomaly, deleting some information cause the loss for other information, so that anomaly can be removed in with normalization. That is exactly why we need normalization. Okay, so this I have already spoke, I would not again get into this. So in case let us say that your database you have not normalized at all, then your database systems can be inaccurate. Okay, inaccurate in terms of the data that it is representing, the data that is stored in different places, and the data that is actually even connected. Okay, so that can be inaccurate. It can give, for a query it can give wrong results. And data modifications may be slow in without normalization, and it can be an inefficient system. Okay, inefficient in terms of both processing a query, modifying a particular system, or handling a particular system, and it might not produce a particular data that you expect, or I can say it as the information that you expect in terms of output. So without normalization, you are actually going to fail in terms of producing the outputs. Okay, so that is why you need a normalization. So I have spoke about why do you need a normalization, but it is for any data scientist, there are certain goals through normalization that a particular scientist has to reach, which means to say that how normalization should actually be affected in your database. So when you look at this, arrange data into logical groupings such that a group describes a small part of the whole. Okay, so entire group should describe a small part of the whole database. So for example, if I am trying to understand how what is the academic part of a particular student, so I should be represented with a small data set than giving me what a particular student is interested in, what is his hobbies, what is his age, what is where he is coming from, his parents name, etc. So these are unnecessary information. So this should be able to give me a subset of that particular data set, which is a part of information that I am interested in. So minimize the amount of duplicate data or redundant data that is stored in the database. That is a major goal of any database that you may be representing with. Then when data modification occurs, it happens only at one pace. Okay, you should go into such normalization in terms that whenever there is one modification only, whenever there is a data modification that has to be done, and it has to be done only in the one place. So that is what you have to remember. Then when you are building a database which you can access and modify the data quickly, efficiently, without compromising the integrity of the data. So which means to say that it has to be quick, it has to be efficient. If it is quick and not efficient, again your database, your whatever the service that you are trying to provide it to the user may fail. Even if it is efficient but not quick, again a user may not use the same service again in terms of using your database for applications or for usage of a particular user. So that will actually create a compromising value for your integrity of your data. So that is another goal of normalization, where you have to maintain your both data integrity in terms of efficiency and easy access or quick access to your database. Rather than easy access, it is a quick access to your database. So in summary, we have learnt about different types of keys today. We started with the primary key, we looked at foreign key, we looked at what is a technical key, we looked at composite key. Okay, we then looked at what are the integrity constraints that are there in your entire system. Then what do we mean by normalization? We define normalization in the terms of maintaining the storing, maintaining and also querying that particular entire database. As why we need a normalization, and most importantly to reduce redundancy of data and to help user to quickly and easily access a particular database. Then we looked at the normalization, we looked at why we need a normalization, and what are the different ways or goals of normalization for any person who is actually developing that particular database. So this is about why and how the normalization is important. So probably in the last class of this module, I would also show you what are the different normalization techniques. From first normal form to fifth normal form, I would show you with examples how a particular database can be made more efficient and quick to handle. So in the next class, probably we would look at different database management systems. What are different database management system? I would just give you a very brief on each of the management systems that are there, whether it is hierarchical, relational and object oriented database management system. Just a brief overview of all of these systems, and next we would look at different normal forms. That is very important point, important part of how your database is handled. So till then, have a nice time. Thank you very much.